Now let's take a look at the product and quotient rules and how they apply to these radicals. Okay, so the product rule for square roots looks like this. If A and B represent, again, non-negative real numbers, then the square root of the product AB is equivalent to the square root of A times the square root of B. And it also works in reverse form if the square root of A times the square root of B, then you can just multiply the radicands together. That's the square root of AB. Now, these should look very familiar because the product rule for exponents said give the exponent to each factor, which is exactly what we're doing here. And it also could be turned around backwards. The reason this works, and you're going to see this coming soon, is that the square root is the 1/2 power. So all of those exponent rules I asked you to learn earlier are going to make a huge difference right here. Okay, let's use that product rule to simplify a few square roots. Now, in order for this to work, in order for me to be able to simplify something, I need the square root and the square to give me a principal square root. I need to be able to take the square root of one of my factors. So those numbers that I asked you to learn earlier, the square numbers, they're very important here. I do not want to call 75 15 times 5 because neither 15 nor 5 is a square number. Instead, I want to call it 25 times 3. Why? Because look at that square root of 25. The principal square root of 25 is 5. And I'm left with 5 square roots of 3. Okay, that's how we're going to simplify. But as always, sometimes there are shortcuts, as in the case right here. When I'm multiplying, and you guys know that I don't use a calculator, so when I'm multiplying, I like to try to break down that square root of 10x to match something that's already there. I see that 5x is a common factor of the two radicals. So I want to take the second radical and break it into that 5x times whatever. It only works when I have a common factor. Otherwise, I've got to go the long way. But here I have the square root of 5x squared, which leaves me with 5. Now, I want to talk a minute about this absolute value bar, because sometimes my students have the absolute value, and I never count off if you have an absolute value when it's not necessary, but I will count off when you don't have one and it is necessary. So let's talk a minute about whether or not it's necessary here. You see that x right there? That is a first degree x. If this is going to be a real answer, x had to be non-negative. So technically, I can slide with it. However, you will never be wrong to throw them in, even if they're not needed. Okay, so let's look at the quotient rule. If A and B represent, again, non-negative real numbers, and B is not equal to 0, then the square root of the quotient equals the square root of the numerator over the square root of the denominator. And like everything else, it's reversible. Again, these are identical to the exponent rules because the square root is the 1/2 power. Your quotient rule for exponents looked like this. So this is the same rule. It is the exact same rule. We're just extending it into the square roots. So let's take a quick look at a couple of examples. This first example, I expect most of you could get 100% correctly, even without this first step that I'm taking. You just think your way through it, and that's great. But if you need to write it out, please always write it out. That is the direct application of the quotient rule. It says to give the radical to both the numerator and the denominator. Then again, that symbol means the principal square root, so I want the non-negative square roots or the positives, and that would be 5/4. However, take a look at this next one. I like when it's numbers like that. I don't want to break down 150 and then see if I can cancel everything out. But there are two equally good ways to do it, and I'd like to take a minute and show you both if you don't mind. A lot of students just go ahead and put it all into one and then simplify what they have as a radicand. 150 divided by 2 is 75. X cubed divided by x, well, if I can write it, is x squared. And then to simplify that, 75 is 25 times 3, and x squared, I believe I can put up there up front and simplify it. So that would be 5 absolute x square root of 3. Again, some of you would prefer just to always leave that absolute x in there, simply because that way you don't have to reason your way through. Okay? But in this case, it's not 100% necessary because of the odd powers here. If x were negative, then these would be non-real numbers. All right, the second way to work through this, and my lazy man way, which again, I do this because it kind of works out the same, but when I'm working a problem in my head, to me this just feels a little easier. I notice that the 2x is a factor of 150x cubed. So I do basically the same thing you do, and I think 150 divided by 2x, okay, 150x cubed divided by 2x, is 75x squared. And in my mind, that's kind of where I stop, but to show you my reasoning, I'll write it out. That's times square root of 2x, and that's square root of 2x. They cancel each other out, and from here out, we have identically the same problem. Moral of the story is this: do whichever idea comes to your mind first, whether it's to simplify first, to identify a common factor first. Just get started and don't make any mathematical mistakes, and we'll all end up with the same exact answer.